In this video, we are going to learn how to define irrational numbers. So when it comes to irrational numbers, we first have to look at the scope of real numbers. So in all real numbers, there's two categories. There's rational numbers and irrational numbers, which we'll be going over in this video. So rational numbers are any number with a repeating decimal that can be expressed as a ratio, both negative, so negative 3/4 is a rational number, and then positive 8/11, that's a ratio, so that also is a rational number. Also, you could have a number like 4.33, which ends after 2 decimal spots. Then also you got 102.25, numbers like that. These are all examples of rational numbers. Irrational numbers, on the other hand, would be a number like the square root of 2, the square root of 3, and pi are both famous irrational numbers, and then you got the decimal format here of the square root of 5, and this will just keep going on forever. So essentially, the way to think about irrational numbers is that irrational numbers are numbers that will go on forever without any sort of pattern to it. So before we get into irrational numbers, let's quickly break down the subcategories of rational numbers. So you have integers, which are whole numbers of negative and positives. And then whole numbers, which is the subcategory, which is just 0, and then every whole number after that. So those are considered just whole numbers. So here we're going to focus, though, on irrational numbers. So let's go over an irrational number in a little bit more detail. So an irrational number is a real number that cannot be expressed as a ratio or fraction. There's two main things to this. So it's going to be non-terminating, meaning it never ends, and also non-repeating. So there's not going to be any sort of pattern. It's just going to keep having random digits for infinity. A quick little summary definition that I'm going to give here is that an irrational number is a number with a decimal that will go on for infinity without any sort of pattern. So here we're going to look at some examples, and we're going to go over is this number irrational or rational. So let's look at our list of numbers here. 99/100. Well, that is a ratio, and so that is going to be a rational number. Here we have the square root of 7. So square root of 7 is going to be a non-whole root here. So that's going to give us an answer of 2.64575,131, and that is just going to keep going on forever. So that is going to be an irrational number. Here we have 27.3 with that little dash over it, and that little dash means that 3 is going to go on for infinity. However, that is a consistent pattern of 3 going on for infinity. So because that's a consistent pattern, that means this is going to be a rational number. Here is an easy one, -12. Can also think about that as -12/1. That is going to be a rational one. Square root of 64 is going to be 8 times 8 equals 64. So those are whole number roots. So this is going to be a rational number. Here we have -e. So we know that e itself is an irrational number. So a -e will give us this decimal that goes on forever here. So that is going to be an irrational number. What about the square root of 22? That is a non-whole number answer that we're going to get. And that number will just keep going on forever without any sort of pattern. So we know that the square root of 22 is going to be an irrational number. And then our last, so again, that little dash indicating the 0.22 repeating means that this is going to be a rational number. So I hope this video helped you be able to learn how to identify irrational numbers. And if you enjoyed this and are interested in learning more about TurtlEd, visit us at www.withturtled.com.